Next, the second subdivision, we have to find the examples of p of x, g of x, q of x and r of x. It should satisfy the division algorithm and also it should satisfy the condition degree of q of x is equal to degree of r of x. Okay. So, this is the division algorithm for the polynomials. So, we have to take the examples p of x, g of x, q of x and r of x. So, let us consider a polynomial p of x is equal to some linear polynomial x plus 5. Okay. Let us consider the polynomial q of x is equal to some linear polynomial x minus 3. Okay. So, if we substitute these two values in the condition, it can be rewritten as x plus 5 is equal to some g of x into q of x value is x minus 3 plus some r of x. Okay. See here, the degree of the p of x polynomial is 1 and the degree of the q of x polynomial is also 1. So, by applying the deductions, here the degree of p of x is equal to 1 and the degree of q of x is equal to 1. We have to find the degree of g of x, right. We know the formula, degree of p of x minus degree of g of x gives the degree of q of x, right. Here we have know the values of degrees of p of x and q of x. Substitute here 1 minus degree of g of x is equal to degree of q of x is 1. So, degree of g of x, I am taking this degree of g of x to the right side, it will become plus degree of g of x is equal to, I am bringing this 1 to this side, becomes 1 minus 1. So, the degree of g of x is 0. Okay. So, the degree of g of x is 0. So, which means that g of x takes any constant number. So, a constant number, any constant number will have the variable's power to be 0. For example, 10 can be written as 10 into x power 0. Here the degree of the term is 0. Okay. So, I can substitute any constant value for the g of x polynomial. So, let us substitute any constant value. And here I am assuming let g of x is equal to 5. Okay. So, I am assuming the value of g of x to be 5 into x minus 3 plus r of x. Then we have to find the r of x. See here, it is x plus 5 is equal to, multiply 5 into x minus 3, which becomes 5x minus 15 plus r of x. Then bringing 5x to left side, it will become x minus 5x, and bringing this minus 15 to left side, it will become plus 15 is equal to r of x. So, which means that x minus 5x gives minus 4x. Okay. Then plus 5 plus 15 gives plus 20. Okay, is equal to r of x. So, we have found the r of x value, right. Thus, the required solutions is p of x is equal to x plus 5, q of x is equal to x minus 3, g of x is equal to 5 and r of x is equal to minus 4x plus 20. These are the required examples which satisfy the division algorithm and also the condition degree of q of x is equal to degree of r of x. See here, the degree of q of x is 1, the degree of r of x is also 1, it can be written as 4x power 1. So, the degree of r of x is also 1, then the degree of q of x, it is x power 1. So, the degree of q of x is also 1. So, this satisfies the given condition. Okay. Next, the third subdivision, We have to find the examples of P of x, G of x, Q of x and R of x, so that it should satisfy the division algorithm and the condition that degree of R of x must be 0. Okay. So let's move for the solution. It is the division algorithm for the polynomials. So let's substitute polynomial P of x is equal to x square plus x plus 1. If the polynomial P of x is getting divided by the same polynomial, that is G of x is also x square plus x plus 1, then the quotient will be 1, right. So if we divide two same numbers, the quotient will definitely be 1. Okay. So I am assuming let G of x is also equal to x square plus x plus 1. Okay. If we divide P of x by G of x, definitely the quotient value will be 1. Okay. And the remainder value will be 0. So it is a constant value. Remainder is getting a constant value. So any constant value, okay, see any constant value will have the variable's power as 0, because 5 can be written as 5 into x power 0, 10 can be written as 10 into x power 0. So the degree of any constant term is always 0, right. So I can take these examples. Let P of x is equal to x square plus x plus 1. Then I am assuming G of x to be the same polynomial, x square plus x plus 1. So if we divide these two polynomials, that is x square plus x plus 1 is equal to G of x value, x square plus x plus 1 into Q of x plus R of x. So we are dividing two same expressions, definitely the quotient will be 1. Okay. So it can be rewritten as x square plus x plus 1 is equal to x square plus x plus 1 into 1 plus R of x. Okay. Now see here, it is x square plus x plus 1, then 1 is multiplied with this expression, the same expression will be obtained, plus R of x. Okay. See, I am taking these three terms to left side, it will become x square plus x plus 1 minus x square minus x minus 1. I am keeping R of x at right side. Okay. Now see here, plus x square minus x square plus x minus x plus 1 minus 1. The value of R of x is 0. So the remainder is getting a constant value. So a constant value will always have the variable's power as 0. Okay. So which means that the degree of the constant term is always 0. Thus R of x degree is 0. Okay. Now the given condition is satisfied. So the possible values are P of x is equal to x square plus x plus 1. Then the G of x value is x square plus x plus 1. Then the Q of x value is 1, and then the R of x value is 0. This is the required examples for this condition. Okay.